So on this channel, I've showed analog signals, I've showed digital signals. Let me show you another type of signal, which is a bit of both. Let's talk about pulse width modulation, or PWM. So PWM is used all over industry for a number of different applications and use cases. Motor speed control, valve and actuator control, lighting control, and heating element control. But what is pulse width modulation and how does it work? So PWM is a technique where you switch an output on and off very quickly, but you control how long it's switched on for and how long it's switched off for. So the digital element of PWM comes by the fact that you're switching an output on and off, but the analog element comes in where you are controlling how long it's switched on for and how long it's switched off for. On the oscilloscope, it just looks like a train of pulses, but the real magic happens when you start to alter the duty cycle of the pulse train. It's important to know that you can't just use any type of PLC to do pulse width modulation. You need a PLC with transistor outputs. You can't do it with relay outputs. The reason for this is because you're switching at a very, very high frequency, which is too fast for relay outputs. So to give you a brief overview of how PWM works with heater control, it's all about the average voltage, the mean voltage. If you apply 24 volts to a heater indefinitely, it's going to give its maximum output all the time. If you give half that voltage, it's not going to get to its maximum output. It's only going to give half its output. By using PWM with a 50% duty cycle, we are only showing the heater element half the actual voltage. So if we want the heater to be only at half power, we don't just give it 12 volts, we give it 24 volts, but only for half the amount of time.